Hey folks, Quilly here, and welcome to another episode of our Unity 3D tutorial on how to make a base building game, and code word Project Porcupine. So, we are finally going to get our wall building up and running over here. I know it's been a few episodes. We've had to create some I don't know, basic infrastructure to get everything working, but the thing is, we're not just building walls here. The code that we're writing is going to be the code that we use to build all installed objects in the game. So we need to just open a couple of things here. It's the mouse controller and the world controller, actually. So these are the two things that exist in sort of Unity space, right? They interact with game objects, which is where we are now. And if we go down to right here, we are now at the point, I think that it doesn't zoom me where I was. We are now at the point where we have everything we need to sort of initiate the building process. We have a button on the screen that says, hey, I want to be in wall building mode. We use that to set the wall building ID, which is just wall because we're very creative there, in this variable here, build mode object type, and we know what tile we are supposed to be building this wall on. So at this point, what we want to do is tell the actual world object over here that, hey, we want to place an installed object here. So that function doesn't exist yet. So what we're going to do is go ahead and create that at this point here in our world class. So void place installed object. I mean, I suppose we could return a Boolean if it was successful or not, but let's just assume a void for now. That's going to be okay. And so what we're going to do is we're going to require a string, which is our object type, and we're going to require a tile, which is the tile where this object gets placed. To do, this function assumes 1x1 tiles. Change this later. So again, we're still only doing 1x1 objects with no rotation right now. So, which is all we're going to need for the walls. So let's get that going on. So really all we have to do at this point, so we've got our object type, we've got our tile. In the world object, we have a dictionary of oops, where the heck am I? Undo, there we go. We have a dictionary of installed object prototypes, and we can get one by name. All right, object type over here. Whoops. Actually, before we do this, we should probably do a check to make sure that this array contains a key of that name. And maybe do something like if installed object prototypes doesn't contain. Right, I like to do it this way. If it doesn't contain an object with that key, let's bail right away. And say something like, so the error is just that installed object prototypes doesn't contain a prototype for key, and then we tell it what the key is. Then we'll get a nice little error message, and then just return right away, because obviously we don't continue. So now we can assume that we actually do have that prototype in there. So what are we doing? Well, basically, we're just going to call, we have a function in our installed object class. We have a static function called place instance. It's placing an instance of a prototype on a certain tile. Well, we've got all that. We've got our prototype, which is going to be this dictionary keyed with a certain keyword, which is object type, will return a prototype for an installed object, and we know what tile it's supposed to get installed on. So there we go. So now, unless I have missed my guess, and I don't think so, let's put in some debug information so that we know exactly where we are. We'll go debug.log, place installed object, and in mouse controller, well, I guess that's going to be run right away. And are you still giving me an error? What is this? Oh, inaccessible. This has to be a public. There we go, no errors. So I think if we hit play, just wait for it to go. Come on. There we go. First run, still compiling. Move it over. If we hit build wall and then click, place installed object gets run. So remember everything that happens. We hit place build wall. It calls a function on mouse controller that says put us in wall building mode and specify that the object ID is wall. And then when we click and drag and release, it's calling place installed object on every single one of those spots. And actually, in memory, it's actually putting the objects in the database. In fact, we're even getting a nice lovely error over here because internally, while we can't see it, these tiles over here all have walls internally. So if I click here, again, we'll get an error because we're trying to build a wall on a tile that already has a wall. So all we're missing are our visuals. Okay, we can work with that. Excellent. So we have images over here, and then we've got our tiles for floors. We have all that working. We also have another folder over here for installed objects. We've got one that's wall, and I think, yeah, I've got it all set up. We're just going to be working with this sprite right over here for now. Wall underscore, because it doesn't have a direction. Everything's going to be set up so that the wall sprite names are based on their neighbors. But we're just going to use wall underscore for now. So what we want to do is end up with a situation where when an object gets created in the world, a wall graphic gets spawned in game. Now we already do something very, very, very similar to that. World controller over here, when we create the world, so we create the world here, and the world has a certain size, then we go and create a game object. At every coordinate of the map, at every XY coordinate, we create a game object, a tile game object, and we link that to the world and say, listen, tell me whenever the tile type changes. Now, that includes tiles that are blank, right? When we run this, there are empty tiles here, but there's still a tile game object right here, for example. And that'll be really handy later on when we want to be able to click on these spaces and get other information or tooltips or all kinds of different things. But we don't want that with installed objects. Whereas the tile map is likely to be quite dense, the installed objects aren't going to be as frequent. We don't want to spawn an empty installed object everywhere and then wait. And especially that's not going to make any sense later on with other characters and things like that. So instead, we want to spawn one of these that gets linked only when we actually create an object. But that's not too bad. We create an object, obviously. Well, it's here. We're not calling anything from world controller. We're just using world controller over here to get its instance because it carries our world. We're just telling the world to place an installed object. But what has to happen is our world controller has to be informed when an installed object gets created. And there's a lot of different ways we could do that. I mean, we could manually call something here, or instead what we could do, instead of calling place installed object on the world directly, we could call it on the world controller. That might be a thing, which wouldn't be too bad. I think, though, we might just use a callback. I think that's going to be okay. So our world over here, what if we give it, we're going to have to go using system over here. What if we give it something like, it's an action that passes an installed object called, how do we name it under tile? I think we went CB. Let's try to be consistent here. Yeah, CB tile type changed. So let's go CB installed object created. So we've got a callback here. So it's going to expect a function that looks like this. Void some name installed object obj. It's going to expect a function that fits this format in some fashion. And we want to be able to register this callback. So we'll make a little function down here. Public void register installed object created. And it needs an action that's got the same signature over here, like that. Callback func. And we're just going to say CB installed object created. We're going to add this one in here. And we'll do an unregister version. Unregister. Same thing, and we just remove it from there. So then whenever we place an installed object, okay, so that places the instance, and this actually returns the installed object. Installed object obj equals this. Now, we don't really need to do anything with it, although I suppose we could return it if we wanted to. But I think all we really care about doing at this point is to say, listen, if our callback's not null, then call our callback with this new object. Someone wants to know whenever we create an object. We just created one, so let's let them know about it. And this will work like an array. You can have multiple callbacks registered to this. They get added up and removed one at a time. And when you call this, it will call all of them. But you do have to check for null. It's a little annoying to me. I guess it's fair, but it would be almost nice if you tried to call the null callback, it would just be like, well, this is an empty instance. Now, it's probably better that you have to be explicit, because then you can do some other checks. Okay, so there we go. So now, in our world controller, we can create the callback. So we are public void on installed object created. All right, sort of that Unity style of name. And it wants an installed object called obj. Create a game object. Well, it's game object linked to this data. Explicitly, I'll say a visual game object. That's the whole point. We're making something visual over here. So this is going to be called whenever a new object gets created. So in our world controller's start over here, we want to tell the world, hey, world, we want to register an installed object created on installed object created. So, hey, world, whenever a new object gets created, call this function for me, will you? Great, thanks. Because these objects might be created from all kinds of different effects and might be destroyed from all kinds of different effects. We're going to want to have another callback for when the objects get destroyed later. But for now, this is going to be okay. So basically what we're going to do is we're going to grab the same code over here that creates our tile. All right, this was creating our tile. Well, we're not going to do that. We're going to call it the obj game object, which I realize starts to be a little rough over here. We probably will want a dictionary. We'll probably want it. Sure. Let's assume that just like we have a map that goes from the tile data to a game object, we're going to want a map that goes from installed objects to the game object. So this is going to be the installed object game object map. Yes, I realize these things are getting pretty brutally named. And again, I think we're going to do, I'm going to finish, like, this episode here should finish with our walls actually working. I think what we might do between this episode and the next one is I might rename installed object to furniture and loose object to inventory. I think that will be less brutally long and also very clear. And also, it reduces the use of the word object because we have game object, installed object, loose object. I still don't like the name item. I think that was too generic, but I think furniture versus inventory, I think that would be pretty good. Okay, so we're going to add our tile to that. And we have names. So we're going to call this one, it should be based on the object dot, can I not get the type? Oh no, right, because it's not public, it's not shared in any way whatsoever. Installed object, let's go to the declaration. The object type over here, let's actually just make you a property, which traditionally would have the capital. I guess it doesn't matter. We can have the lowercase. But get protected set. So we can't set the object type directly, but we can read it this way. Oh. Oh, wait, what did I do here? Wrong callback. On installed object created. There we go. Excellent. All right. So now we should be go object.object type, which again here at this point will just be the word wall, right? It's just going to be called wall, and it wants the coordinates, which the XY coordinate, the installed object doesn't know it directly, but it will have the tile. So I guess again, we'll just make it a public accessor. I mean, you can do it read-only. There's different things to do. So, and protected set. So only within this function can we set. Can we go, object.tile equals whatever. Only within this class can we do the setting, but anywhere can get it. So again, over here, obj.tile.x, being inconsistent with my cases with my parameters versus, or my sort of class variables versus my properties. So my apologies for that. We'll try to standardize something with case a little bit later on. But there we go. And then the same thing here and here. So we're getting the object belongs to a tile, and the tile has an XY coordinate, so we're using that. Again, everything here, fix me, does not consider multi-tile objects nor rotated objects. That will come later. Walls don't need any of that. So we're going to set the position. So the object's going to be positioned on top of the tile, which is reasonable. The coordinate, the position, everything gets set the same way as the tile graphic itself. We are going to add a sprite renderer to our game object so that it actually renders a graphic. Although, by default, all the tiles were empty to start off with. That's not going to be the case. We are going to want to assign a sprite to this equals something. And we probably will want the callback. So the sprite, for now, let's hard code it in. The sprite, yeah, how do we get our index of sprites? Well, there's a few different ways. Let's hold off on this for now. Let's go ahead and leave it null. Give me a moment, we'll fix this. And we do want to know when our objects info changes. On our installed object, we will want a callback, just like we have in the tile, so that we can inform other parts of our system when something on this object changes. Almost basically anything on this object changes. Certainly the type, but maybe objects can take damage later, and we're going to want to visually represent that. For doors, we're probably going to want some sort of little progress indicator of the door opening and closing. So this will probably internally track some sort of like door open %. But externally, we're going to want to use that to animate the door opening and closing, for example. So there's going to be a lot of things that will want information. So just like we used over here, right? We have the tile type change callback. I think what we're going to do is have, first of all, we need to do using system. That way we can use the action keyword. If you don't use system, I think you can still use delegate. Actually, you might need system even for delegate. Anyway, let's just move on. So we're going to have a callback here. So this is going to be an action. This is going to be a function we call. The function will obviously need to expect an installed object reference. No problem. We can do that. Callback, like anything changed. What did we call it, the other one? Called tile type changed. Really is like on changed. Do I have a D at the end? Yeah. And basically, when in our accessors or other functions, like anytime we make any change to the data on this installed object, we're going to want to call this. And it'll be the responsibility of the person at the other end to, read through all the properties and, display things appropriately. We could do it more granular. We could have a callback for every little piece of data that changes. Like later on, if we get something like float, hit points or something like that, we could have a callback for hit point change. But I think that gets kind of awkward. So I think this is going to be fine. And again, we want a public void register on change callback. So it needs an action that expects an installed object and callback func. And maybe inconsistent with some of my names, we'll do a pass later to improve that. So CB on changed plus equals that function, and we'll offer the ability to unregister as well, like that, and just remove it. And I mean, we don't have any changes yet. We're just sort of future-proofing. But I suppose, really, it wouldn't be inappropriate. Now, as I say, to call the, not register, but call the callback right here, in a sense. Because we've just created the object, and obviously, you know, it's got some fresh data. But the problem is, I don't think until we return the new copy of the object, nothing will have the opportunity to actually register a callback. So it makes no sense to call it there. So right now, this callback is not going to get called. But it will in the future. For doors, for items that get damaged, for all sorts of things like that, it will definitely get called. But going back to our world over here, we're going to assume that we're going to want to register a callback. Now, register... no, sorry, not the game object. The data. Register on callback change. So, and then we'll need another function over here. It actually doesn't even need to be a public, does it? I don't think it does. On installed object changed. Like that. And we pass it there. Debug.log error. Not implemented. There we go. So we'll know if things are being called. It's all good. And we can make sure this is working by just logging. So this should get called whenever an installed object gets created. And then we pair that installed object up with an actual game object. So it's got some visuals. We register some callbacks. Excellent. What we have to do is get the right sprite to show. Unity asset. So there's a way to use, to find a prefab. I haven't really done it much. But you can do it. What's the function? There we go. Manual install. No, because I don't want to have a reference. Loading resources at runtime. Yeah. I should have had it ready ahead of time, but my bad on that. It's just resources.load, right? Oh, resource.load, then you need it in a resource folder. Is that what we're looking for? I think so. I think so. Now, does the top level have to be... Alright. We're gonna try some things over here. Yeah, but I want to get this sprite by name. Tell you what, let me come back to making that in a better way. For now, in our world controller, we're going to set up a public game object, or, sorry, public sprite wall sprite. Fix me! So we're just going to hard code in a reference to the wall sprite in the world controller over here. Same way we've done the floor sprite, actually, which I just realized. Where's the floor sprite? We should group them together. There we are. Fix me. So we're not going to want these hard-coded in. Instead, we're going to want basically a database where the type of the wall or some other thing will generate the string that we use to load the thing. Okay, we are getting... Oh, we're getting an error here. Because I am now, in this script, using system, because I want to be able to reference the actions and things like that, we have a reference to random. Well, system has a random, and Unity Engine also has a random, and we want to use the Unity Engine variant over there. So we have to make it unambiguous which one we are referencing. Okay, so there we go. That is in there. So it's expecting a wall sprite. We're just going to give it the one wall sprite over here. Again, in my actual sprite over here, I have a bunch of different variants so that we can use walls that connect in different ways, but we're just going to use this one over here for now. And then we'll improve things later on. That will be one of the steps. We will have to clearly use a more sophisticated way to reference the sprite, so that we don't have to, hard code all these things into the controller class and then the inspector over here. And also we want the correct sprite to be chosen depending on how walls are supposed to be connected together. So that will come later. So we do have a reference to the sprite, which is great, which means our callback in world controller over here, our callback, which happens when an installed object gets created, we're going to remove this note. Fix me. We assume that the object must be a wall, so use the hard-coded reference to the wall sprite. So, wall sprite. There we are. So, fix me, fix me, fix me, fix all the things. So now, whenever an installed object gets created, we should be creating a visual game object to represent it. We should put it in the right place. We should give it the wall sprite, and we'll also register a callback here that doesn't actually do much. We also keep a reference to it in the map. This is a map that maps from the installed object to the game object, which is going to be relevant down here. Although right now, again, we're not using it. So I think, unless I've broken something terrible at this point, we move over and we hit build wall, and I clicked, we get a wall! And we get lots of walls, and a straight line of walls, and more over there, and more over there. Excellent stuff. And if we look at the world controller, we've got all our tiles, but if I scroll down, we should find walls. And they are indeed... Oh, because it's hiding behind the button over here. That's unfortunate. I wanted to see it in the inspector view. But that's all right. But we have a bunch of wall game objects over here that are linked through callbacks and a dictionary to the actual data behind the scenes. And every time the actual wall data gets changed, not that there's any way for us to change object data yet, but once it does, the callback will be changed and the visuals can update in real time, which is wonderful. There we go. And if I click here, and we'll get the error over here. Ooh, and actually a second error because we're not actually checking to see if something gets returned as null. Where's this happening? Whenever there's an error in a dictionary lookup, you can't just double click on it to get the reference because it's sort of internal to some of the internal code. You have to look a little bit further. See, it's like this dictionary.cs code at line 391 is actually the thing that threw the error, but it's because of this call in world controller line 150. So we go to world controller line 150, and we find out, oh, uninstalled object created. So we are creating it. Really, are we? Oh, yeah, because place instance, if there was already an object there, this will return null. So we should check for that. If obj is equal to null, failed to place object. Most likely there was already something there. I'm not going to write anything to the error log because place instance already does that for us. Mostly it's just important that we don't call the callback. So just return at that point so that we don't call this subsequent callback. And that should, now, it should still set up one error that we put in to say, hey, you can't place an object here. There's already something here. That's the floor. Good thing that the floor thing still works. The bulldoze still works. And then the wall over this way is great. And if we click here, we'll get the one error trying to assign an installed object to a tile that already has one. And then the whole that whole function, the whole process of placing a tile, then just bails out. So we don't actually create another tile. We don't create an extra visual or anything like that. We just say, whoa, 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 okay, yeah, we can't place a tile here. That's fine. We're just going to back out, and the error is good. And if I do this, what it should do is it should place all the tiles, but give us an error for the one spot. Yeah, so it still places all the others over here, which is great. Now, right now, bulldoze does not bulldoze any objects. And in fact, we probably want bulldoze to work a little bit differently. It's almost like if you're bulldozing a tile here, well, a few things. First of all, we don't want to be able to build walls on empty spaces. Our idea will be you build walls on top of the sort of floor scaffolding. So that is one thing. And secondly, whatever sort of bulldoze/destroy kind of function that we end up with over here, when we click on a tile, what we really want to do first is if there's an installed object there, we want to blow up the installed object. And then if there's nothing there and you're just clicking on floor, then maybe you want to destroy the floor. I mean, obviously this bulldoze/destroy function is going to have to be way more sophisticated and context sensitive down the road. I mean, we're going to want something else, and we're not going to necessarily even want things to be instantly destroyed. We want someone to walk over there and destroy it for us. Maybe we don't have a bulldoze button. Maybe instead what you do is you click on a wall tile, and then like a little window pops up describing this thing, and you hit like destroy there. There's a bunch of different ways that you can interface with this, right? Like if you think about Prison Architect, most of the furniture that you put in, the way you destroy the furniture is you click on the furniture and you choose either dismantle or destroy. Dismantle will package it up as sort of an inventory item and then place it in storage, for example. Whereas walls in Prison Architect work a little bit differently. And I'm trying to remember in RimWorld, I think you can bulk destroy things that have been created. But, you know, again, there's a difference. I think Bulldoze, I think we'll want one tool that is just there to remove objects. Like, I would probably want the ability to quickly clear a room. Like, I got a room, it's got some furniture in it. You know what? I want to be able to take the whole room and clear it out, but not actually strip off the floor. So I think there would have to be a button that is explicitly something like remove floor, which is something that RimWorld does, for example. And I think Prison Architect may do something like that with foundations as well. I'm not sure. But yeah, I think ultimately we'll want two buttons. So this Bulldoze button should just be renamed to remove floor, and then we'll have some other a button that lets you box select and destroy installed objects, which would be nice. But hey, we got our walls, baby! Boom! Oh, that took a little bit while to load, which makes sense. That is instantiating a lot of stuff. Oh, and it probably doesn't help. Of course, every time, it's rule of thumb, anytime you're doing something in Unity and it's like freezes for a second, and you're like, oh man, my code is unoptimal and it's really slow, why don't you go and just check to see how much you're spamming the console? Adding text to the console is really slow. For some reason, this is a really unoptimal thing in Unity. I don't know if it has every time you do a debug.log, if it changes a list, allocates more memory, and then re-renders the console. I have no idea. But this is obviously running a lot for every object that we're putting down here. And this was like, what is it? Well, it's not quite 20 by 20, but if it was, it'd be like 400 times. So 400 times it's adding an entry for place installed object and the callback for on object created, which are nice little handy callbacks to make sure that things are working. Now we know they're working. So let's see. Let's try this again. We'll do stretch it out here like this and let go. Oh, that's the floor. Build wall. Boom. Instant. No delay. There we go. Oh, that one was the delay because, again, it's spamming the error log or the console with error messages. So there you go. Anytime something seems a little bit slow in Unity, check to see if you're just spamming the console, because that would probably be it. One thing to note, you could leave these console commands in there, and when you do your build for Windows and Mac and Linux and all those things, the console doesn't actually exist. I assume that if you're not running in the editor, I might be wrong about this, this just returns instantly and doesn't do anything. Or maybe it still does have a text log, but maybe updating the text log is actually easy and simple. I mean, if it's a list, you're just appending to the end. It should be relatively easy. It could just be that the slow part is rendering this little view over here, which might mean in production, it's perfectly fine that you spam debug.log a lot. And again, in production, it might just disable the debug.log function completely, and you may be able to redirect it in different ways. I actually haven't looked into exactly how that gets optimized in production, but there you go. So we've got walls. Obviously, they don't do much but yet right now. But what's important is we don't just have walls. We have support for any kind of furniture, any type of installed object can now be supported, as long as it's just a single tile and doesn't rotate yet. That will be, I was going to say next time, but literally I think the next video that I'm going to do is actually going to be my post-mortem for my Ludum Dare game. The Growth Industries game, where I'm going to try to talk about what went well, what went wrong, break down a couple of the mechanics, and just try to give just general sort of feedback on, hey, do you want to participate in a game jam? Here are the things that are good ideas, bad ideas. Here's what you should focus on if you are participating in a game jam yourself. So I think that will be the next video. But then after that, we will probably, well, we're going to continue to improve our little building interface over here. We may not worry about, I don't think we're going to worry about multi-tile stuff yet. I think in the next video, what we're going to do is try to get the walls to look better, right? So that's going to imply a few things. First of all, it's going to imply getting rid of this sort of like direct reference to a specific sprite over here. Instead, we're going to have some sort of like dictionary/database where we're being told what an object's ID is, and then we are looking up the appropriate sprite at that point. And in addition to that, some objects, like walls, will actually not just load a sprite directly. So the ID of this object is just wall. But we're not going to have a sprite just called wall. Instead, it's going to be wall underscore or wall es or whatever, depending on what variant it is, right? Like this block right here, oh, which I can't edit because I'm in play mode, but this block right here, right here, this would be called wall underscore NEW because it's got a neighbor to the north, the east, and the west. And then in that case, we will use this variant of the wall. And it's notable, walls can't be rotated. You can't just like use this same center block here for any wall that's connected in 3 directions because the way the light and the shadow goes. We can't just rotate a wall. We have to have 4 different versions of the walls here with the triple connections, for example. Same thing with these corner pieces, right, that have 2 neighbors. This one has a neighbor to the east and to the south, which is why this one's going to be wall ES, right? So some of our furniture will have a function that sort of procedurally generates the correct string name, the correct name of the sprite based on the neighboring stuff. And we're going to have to figure out exactly how we're going to do that and to load that all into a sort of a sprite database. But that should be okay. We'll have to do that next time. Thanks for watching, folks. Bye-bye. Thank you very much to all the November supporters over at patreon.com/Quill18creates and to these mic check level supporters. We've got Alex, we've got Wes Oldenbuyving, we've got Andrew, we've got Craig Mortel, Philip Nichols, Neil Blakely Milner, we've got Speedy Savant, we've got Valiant Cake Fiend, Radel Del Peso, Aaron Toivson, maybe? Marius Fieldvold, Tim, Julian Auger Lafont, Steven Stager, or Stagger, we've got Michael McClintock, and Bunny, and also everyone who's just watched, shared, favorited, subscribed these videos. You really make a massive difference when it comes to keeping the series going and making everything just interesting and awesome. And just thanks for watching and thanks for supporting. See you next time, folks.